A 7/10 of a kilogram block eraser is in equilibrium on an incline with an angle of 25 degrees. Find the normal force of the incline on the eraser. All right, so again, we've got an equilibrium problem. Okay, it simply tells us we're in equilibrium this time. So we know that. All right, we've got this eraser setting on the incline. That's the new part. There's an incline here. So there's going to be some variations with the take our axes and to rotate them so that the x-axis is parallel to the surface and the y-axis is perpendicular to the surface. This helps because now we're only going to need to do vector resolution for one force instead of for two forces, because now the normal force is always perpendicular to the surface. So if we make the x-axis the same direction as the surface, the normal force is going to go in the way the y-axis is. And the frictional forces are always in the same direction that the object would be moving, or the opposite direction the object would be moving. So it would also be along the x-axis. Now I drew two of these so that I could draw my free body diagram with it at an angle as well. So I'm going to go ahead and draw it something like that. Okay, so now I want to go ahead and label the forces that are acting on this object. Well, on the eraser, we know this eraser is on or near Earth's surface, so there's a gravitational force acting on this in the straight downward direction. Okay, we also know that this eraser is on the incline, which is a surface, so there's a normal force perpendicular to the surface, and that's why we rotated the axes. So the normal force is now right up along the y-axis. Okay, and then we know that there's also going to be a force of static friction, and that is always going to be in the opposite direction that the object is moving or would be moving. Well, this would slide down the ramp that way, so I'm going to put the force of static friction will be going up the ramp. Okay, so now I've got my free body diagram drawn, and when I look at it, I've got a force in the y direction, a force in the x direction, and then I've got this force, the gravitational force, that is in both. So the first thing we need to do is get the components of this force. Well, we're going to have a y component, because this is the y-axis, and I'm going to call it actually the perpendicular component because it's the part of the force that's perpendicular to the direction the object would be moving. Okay, I'm going to label the other side as the parallel component. Okay, now the first thing I'm going to do is go ahead and find these components. So I know the gravitational force on the eraser is not given to me, so I need to find it. Okay, so I know the mass of the eraser is 7/10 of a kilogram, and I know the angle was 25 degrees, and that is the same angle that is right here. In class, I'll show you guys how we get that same angle. It's a little bit of geometry, but it's the same angle. Whatever's given to us is the angle between the gravitational force and the y-axis. Okay, so we've got our mass. So let's go ahead and find our gravitational force so that we can then find the parallel and perpendicular components. So to find the gravitational force, we use our equation. The gravitational force is equal to the mass times the gravitational field constant. So the gravitational force is equal to 7/10 of a kilogram times 9.81 newtons per kilogram, which ends up being a gravitational force of 867 thousandths newtons. I kept 3 decimal places this time. So we got our gravitational force. Then I want to find the components. Well, let's go ahead and find the perpendicular component first. So I look at my angle. The perpendicular component is the adjacent side. And then this gravitational force of 6 867 thousandths is the hypotenuse. So I've got adjacent and hypotenuse. I'm going to use cosine. So the cosine of 25 degrees is equal to the adjacent, which is the perpendicular component of the force, divided by the hypotenuse, which is 6.867. Multiply both sides by 6.687, and we get the perpendicular component to be 6 22 newtons. Moving on from there, I'm going to find the parallel component. So the parallel component, well, this is the opposite side, and that's still the hypotenuse. Opposite and hypotenuse is sine. So the sine of 25 is equal to the parallel component over the hypotenuse, 6.867. And go ahead and solve, and we get the parallel component is 2.902 newtons. Okay, now we are asked for the normal force of the incline. Well, this is my normal force right here. I need to know some other things, okay, because I don't have an equation right now that I can use. What do I need to know is I need to know it's in equilibrium. And when something's in equilibrium, we know the net force on that is 0, which means the net force in the x direction is 0, and net force in the y direction is 0. So I look at this. I could do both of those, but when I look at my picture, I see that the normal force is in the y direction, so I'm going to go ahead and just skip the x direction for now and focus on the y. On the y direction, the normal force is pointing up, so I'm going to leave that as the positive direction. And the downward portion is the f perpendicular. And since it's downwards, I make it negative. And those two are going to add up to 0. And I can substitute in. Well, the normal force plus negative 6.22 is equal to 0. So our normal force is 6 and 22 hundredths newtons.